we get started? Okay. Good morning, everybody. My name is Sunil Patil. I'm from Nuage Networks, part of the product management team. With me today, I have...
I'm Noboru Yamata from Fujitsu. I'm a manager of technical design of K5.
I'm Yotaro in Fujitsu. I'm in charge of Officer K in Fujitsu.
Thank you. So today we'll be talking about how Nuage integrates with IRanked and enhances the capability and then automates the switch Tor orchestration to make the networking for the bare metal IRanked ports happen. So before we dig into that thing, just quick overview about what Nuage VSP provides. So Nuage VSP is a SDN controller. So we provide connectivity for multiple types of workloads, be it VM, bare metal, containers. We do integrate with multiple cloud management systems like the key one is OpenStack, but we also have integrations with CloudStack, VMware, and container orchestration systems like Kubernetes and OpenShift. The beauty of this solution is that we can work with any type of workload. We support multiple hypervisors, ESXi, KVM, Hyper-V, and as I said, we can work with multiple cloud management systems, and it's totally flexible, and you can have a mix and match of any of these items. Quick overview about the IRanked integration. As you guys know, OpenStack controller, we have a Neutron plugin for Nuage. The Nuage Neutron plugin talks to our policy layer, which is called as the virtualized services directory, and that in turn orchestrates the Tor. In this case, it's a Nuage network gateway. We have two variants of it. One is called as the VSC, and another one is the WBX. It's a 40 gig versus a 100 gig variant. So the total automation is happening from the controller to the VSD to the Tor switch. As you guys know, the IRanked controller, which is running the API server, the conductor, and the DHCP server, TFTP, they're all based here in the controller. The controller joins the underlay network of the DC fabric, and so are the bare metals which are hanging off of here of this gateway switch. Just for the sake of diversity, we are also showing a hypervisor which is running VMs, and this could be containers as well, and that's also connected to the same data center fabric. To get into the IRanked stages, right? The first stage, as you guys know, there's a bootstrapping stage happening where we do bring up the bare metal with the deploy image, and we are doing some collecting some information from that. So for that to happen, what Nuage does is Nuage automates the networking needed to connect the IRanked controller so that they can talk to bare metals. So we create a L2 domain, and also the controller is talking to the bare metal using the IPMI network to start it and restart it as needed. So as soon as the L2 domain is created, so we get into the deploy phase. So the deploy image is being downloaded from the controller into the bare metal. And we do provide, for that L2 domain, we do provide security groups. So you can assign a security group for the provisioning network and the cleaning network and so on and so forth. Yes, so as the second step of this, so we know that the user image is loaded onto the bare metal, and then it is restarted. And at that point, the IRanked ports have to be switched from the provisioning network to the tenant network. So Nuage network plugin, which is running as part of the OpenStack controller, it intercepts the port binding events coming from IRanked to Neutron, and then based on that, it relays that information to the VSD, which in turn goes to the VSC or the network gateway and provisions the right port and puts that in the right overlay tenant network. So in order to do that, we need to know which bare metal is connected to which port of the switch. So we do topology discovery either through LLDP, and we also support manual configuration of this topology information. So this is all taken care in a completely seamless, automated manner. So at the end of this process, the bare metal, in this case, bare metal 1 is being booted and put in the tenant network, and that is put in the final tenant network. And assuming that there is also a VM in the tenant network, and now they can start to talk with each other. List of key features which Nuage supports with IRanked. So we do support orchestration for VSCs and WBX, which are the Nuage gateways. As I mentioned, we support the topology discovery or introspection using LLDP or manual based for provisioning networks. Multi-tenancy is supported, which is supported by upstream Neutron, and then we just enable it through Nuage plugin. As I mentioned, security groups are supported along with port security. So these are supported for both for provisioning network and also for the tenant networks. And you can use it for provisioning, cleaning, and tenant. So which means when you do apply the security group rules in OpenStack, they get decomposed into the appropriate ACLs and get provisioned on the hardware gateways. We had two unique features. I'll get into the details of that. One is the VLAN Transparency, and another is VLAN Trunking. I think most of you may have seen these features working in a VM environment, but we have taken the same model and we have applied it to IRanked Baremetal, and then we seamlessly orchestrate the VLANs into the desired overlay networks through our VSD automation. And the last feature here is port groups. So we do support IRanked port groups as well. So just a little bit of details about the VLAN trunking feature. So if you guys are aware, I think this was introduced about 1 or 2 release cycle ago through a VLAN aware VM blueprint. So there is a concept of trunk port and sub port. So you can create multiple VLANs on a given Neutron port, which is on a trunk port, and then each of the sub ports have a different segmentation ID, and then they can belong to a different Neutron tenant networks. So which means there is a trunk port, usually bound to VLAN 0, and then there is sub ports like 100, 200, or 300 here, belonging to different VLANs, and then you can map them to different Neutron networks. So the modeling is completely based on upstream VLAN over VM model for this one. And one thing to note here is when the packet comes from the VM is in this case it's a Baremetal, there's a typo here. So that comes from the Baremetal, so it gets tagged, and then the VLAN tag is removed before it enters the hardware TOR, and then when it gets mapped to the desired overlay network, and then just before it's delivered to the destination Baremetal, that's when the tag is reapplied and then sent to the Baremetal. Minor variant of this is a VLAN transparency feature, in which case, again, the VLAN is being generated by the Baremetal, and the difference here is the VLANs are carried transparently to the fabric. So we are not trying to, if there are 3 VLANs coming out, we are not trying to map each of the VLANs into a VXLAN into the tenant network, but instead of that, these are transparently carried to the fabric and delivered to the destination, the Baremetal. And this is, again, the modeling or the provisioning model is completely aligned with how the transparency works for the VM use case. I think simple sample Baremetal configuration, how this will look like once you use the collection of these features and you want to go for a deployment. Assume that you have a Baremetal which has 4 ports. You could take 2 ports each and then put them in 2 port groups. So basically, you're having a lag or MC lag. Essentially, MC lag would be more appropriate because you want to have resiliency. So you have 2 ports in one port group and the other 2 ports in the second port group. And then on the first port group, you could potentially apply VLAN transparency. So any packet going on that port group with VLAN tags, they will be carried transparency to the data center fabric. And on the port group number 2, you can enable VLAN trunking. So any VLANs which come out of the Baremetal on that particular port group, you can, through configuration, you can map it to the desired tenant networks. So that's all seamlessly possible. And in case of the trunking also, we do support security groups. So we can have separate security group for the trunk port versus the sub port. So these are essentially different Neutron ports, and you can hang any number of the security groups for individual sub port and the trunk port. So with that, I will pass it over to the Fujitsu team, and they will tell us how they are leveraging these unique Nuage IRanked capabilities to offer a Baremetal as a service in their new public cloud offering. Thank you.
So could you turn it on? Okay. Oh, thank you, Sunny. At first, I will briefly explain about our Fujitsu cloud services, MetaArc and K5. Here shows MetaArc's portfolio. MetaArc is our brand name that contains a comprehensive set of cloud technologies, solutions, services, and ecosystems. K5 is a key part of Metak. It offers public or virtual private IaaS based on OpenStack. K5 is the enterprise IaaS launched from Japan, and now it's available in other countries. It's the largest OpenStack deployment. We operate 8 regions around the world and plan for launching more regions based on the new platform I'll explain later. Sorry, skip this slide. Here's our strategies. K5 offers a lift and shift model to migrate the existing system of our customer to K5 platform. In the lift step, we have to move the on-premise system, such as VMware-based system, to K5 as it is. Then the lifted system can be transformed to a cloud-native architecture. We call it shift. Today's talk mainly focuses on the lift step, about Baremetal services, but in order to realize both steps, we'll introduce a new platform. So I'll talk about the new K5. We are happy to announce that Fujitsu selected Nuage VSP for new K5 SDN solutions. Thanks to the powerful combination of OpenStack and Nuage VSP, new K5 provides massively scalable virtual overlay networks and highly available systems. And also, we'll offer the enhanced Baremetal service on new K5. My colleague will talk about the technical details about Baremetal.
Thank you. So let me introduce an outline of our new Baremetal service, which is now planning and under development. And these are 3 key points. First, our IRanked-based neutral Nuage VSP provides multi-tenant networks for Baremetal servers. So Baremetal servers and VMs can connect each other via tenant networks. And second, network flexibility on Baremetal servers. We are planning to support flexible networks like tagged frames or virtual bridges and so on. And third, ESXi deploy support. We have developed a new IRanked driver for ESXi deploy, and which highly encourages to lift existing VMware enterprise workloads to our public cloud. So in the next several slides, I will give a little deeper explanation of these 3 key points. Our IRanked-based, which means the Baremetal service is connected to other OpenStack services in the native OpenStack way, like Nova and Neutron and so on. And thanks to Nuage VSP technology, Baremetal servers and VMs share the same L2 or L3 networks, so they can communicate to each other directly. And network flexibility by Nuage V4 technology, which can handle tagged frames generated by Baremetal servers, even if there are some virtual bridges and some VMs in Baremetal servers. This feature extends acceptable system structures for lift and shift existing enterprise systems. And ESXi deploy support. IRanked needs IPA to send heartbeat for updating node provisioning statuses. But, however, we cannot use IPA in the official flow of ESXi scripted installation. So we have developed a new IRanked driver and integrated it to our Baremetal service to support ESXi deploy. And this slide shows how the driver works. First, generate PXE config with a UUID of a node, which is to be provisioned, because ironic Heartbeat API needs node UUIDs. And second, PXE boot sequence started. And third, download ESXi Kickstart script from some web servers and execute the installation process. And finally, the Kickstart script retrieves some parameters like the node UUID or the IP address of IRanked controller and sends heartbeat to IRanked controller after the installation finished successfully. So, conclusion. We have been improving our IaaS to encourage lift and shift existing workloads to our private cloud, public cloud. And upcoming our Baremetal service achieves 1, all IRanked based and all OpenStack based, and 2, multi-tenancy and flexible network support, and 3, supports EXA deploy. And that's it. Thank you for listening.
Thank you.
Thank you.
We have a couple of minutes. If there's any questions, we can take them, I think. Sure, go ahead. Upstream for committing the orchestration part of the gateway?
Yeah, so you know how we have the problem with metadata agent being available for deployment? Do you know if there's any upstream OpenStack plans for exposing the metadata agent to IRanked services? So
currently, we are not supporting the metadata agent yet, but once we start looking into that, then we'll see if we can upstream that effort, I think. Thank you.
Thanks.